Hello, everyone. I see there are 15 of you here, or I guess 14 since I'm a person. Um, so yeah, this is the Makery. We are not really a makerspace, but we're kind of like for the CS kids that want to do making type stuff. You guys can come here and learn about how to make different things. So let's see. How do I control this PowerPoint? Yes. Okay. So we'll start with a couple introductions. So hello, as you can see, I am Mudit. And JJ, if you want to turn on your video or just say hello to everyone.
Hello, I hate the picture you chose, so don't think that's actually me. Um, hello, I'm a second year CS student and I'm helping along too.
Got Steven. Steven's also on our admin team. I believe he's here. Steven,
Yes.
say hi if you're here.
Yes, hey, can you guys hear me? Hi, I'm
Yes.
Steven. I'm a third year CS major. This is my third year in the Makery community, so nice to meet you guys.
And hi, I'm Pulkit. I'm a first year grad student, but I helped start the Makery my sophomore year at Tech. Yeah.
Very cool. Okay. So now these are just a bunch of links for all of you to open. So this first one, that's just how you join our mailing list. You'll see all the different things we have. So we'll send you reminders for our Friday meetings. And then the Discord is for everyone to just chat with each other, have fun, become friends. Same goes for Slack, and then follow us on Instagram and join the Facebook group. So all these links, we'll send out this PowerPoint and a recording of this video after the meeting. And for now, we'll just have JJ send he can send all these links in the chat for you to click easily. Okay, moving on. So what is the purpose of the Makery? So obviously it's a little bit different this year than it is usually. So usually we have workshops and we have projects. So the workshops are for people with a little bit less experience to come in, learn things from us. We teach a bunch of different workshops, as you can see, are potential workshops. There's a lot of different topics. So we sent out a form. The link is right there, tinyurl.com/gtmakerysurvey 2021. So just fill that out. Tell us what kind of workshops you want us to focus on. We've gotten a couple responses for that, so we're going to structure all of our different workshops based on what you guys want to learn this year. And then other than the workshops, we have big projects that we have like large groups within our club working on. So our main project right now is the go-kart. So right now it's a little bit hard for us to show you the go-kart, but it's about 2.5 feet wide and it's 6 feet long, about 2 meters. If any of you are Imperial, nope, Imperial is, I don't know what units are.
So these are like the
Yes.
motors. So we'll go ahead and switch you to a screen where you can see what's going on.
Just use that one.
Yeah, so you can see this motor. So the motors have a bunch of wires coming out of them, and we're actually able to send them power and control signals.
Yes.
So we're using these to control or to drive the car.
So I'm sure most of you guys know what Lime scooters are. So those motors are from decommissioned Lime scooters, and we're building a full go-kart with 4 of those motors. Okay. So this semester, it's obviously a little bit different because it's Corona time. So what we're doing is just having every Friday, we have these little live stream tutorials, so more like what our workshops are usually like. And projects, we want some of our more experienced or even inexperienced members to join us for some planning meetings and eventually some live work sessions that we'll do on these projects. So right now, those are still in the process of being planned, but we'll send messages in the Discord and the Slack, and we'll also send you guys emails once we have more planning done for the project meetings. Okay. So, does anyone have any questions about what we do as an org or anything like that before we move into our Arduino tutorial? Feel free to drop questions in the chat or just unmute. Okay, so I guess, yeah, just for all of you that are interested, it seems like there's quite a few of you so far. We really want you guys to we want this club to be relatively low commitment. You guys can just come and learn about Arduino stuff. So that's why we have it as just live streams every Friday. We want it to be a place where you guys can make friends, because obviously, unlike most computer science clubs, a lot of you don't have the materials to follow along at home. So we'll send out a link to an Amazon for like maybe a $20 Arduino kit that you guys can get and follow along with. That's completely up to you if you want to do that. We really want you to just come to these live streams, maybe make some friends while you're in these meetings, and just learn about Arduino, Raspberry Pi, 3D printing, anything, whatever you guys want to learn is what we're going to teach you guys. Do we have things like CNC machines or laser cutters on campus? So, probably answer that. You've been here for a while.
Yeah, so there's a couple different maker spaces on campus that will give you access to laser cutters or CNCs and that kind of stuff. Unfortunately, the Makery, we're not a full-on makerspace. There are plans to have that happen in the future, but obviously because of COVID, things have slowed down quite a bit. So I'm not sure that that's going to be here in a reasonable time frame. But on campus, we have the Invention Studio, the Hive. So the Invention Studio is run by a lot of the mechanical engineering department folks. There's the Hive, which is run by the ECE department. There's the Aero Makerspace, which is run by Aerospace. There's the GVU Lab, which is a small makerspace located in the bottom floor of the Tech Square Research Building. So those are all places that you would be able to access a CNC machine or laser cutter or any kind of tool you would need to fabricate anything you can think of. Yeah, I think that's pretty much the list of all the things you can get. There is a class in the College of Computing, CS 3651. It's a class that anyone in the devices thread has to take. There are some resources in that lab, so if you're in that class, you can do some stuff. But I think that's pretty much it.
And specifically for the CNC, one of our club's projects is to make our own CNC. Obviously, that's somewhat put on hold with COVID, but if you guys are interested and you stick around until next semester, we would be using those.
Yeah, so we do teach how to use those kinds of tools. So the room we're in right now, which maybe I can give you.
Just pick up this laptop.
Okay. Yeah, just switch this.
All
right, so we're in this room. And so you can see, I don't know how well you can see the room, but there's a laser cutter in the corner. There's band saws, drill presses, chop saws, and then there's a bunch of like electronics equipment. So all that is stuff that we have access to, and over the course of a normal semester, we would be teaching you how to use. Obviously, COVID has made us all very, very happy with our lives. So we can't really do that now, but obviously, if you guys are interested, we can still kind of teach you guys how to use these tools. And then if you're able to find access to one at home, you can use it there. Or obviously, once you get back to school, you'll be immediately aware of how to use these tools.
Yeah. And so especially like you're asking if we teach that. So if that's something you really want to learn about, make sure to drop that in the survey that Jay just sent the link. It's interestform10url.com/GTMakery survey 2021. So as long as you put that in there, we have an option for you to just like type in something unique that you would like. So just drop that in there and we'll see if we can make workshops centered around what you guys want to see.
Yeah, so like in the past, we've done workshops where we had people like draw up a design for laser cutting and then we laser cut it together. So like 1 week, everyone designed whatever they want. Then the next week, we took all your designs and with you guys there, we actually cut them out on the laser cutter. We've done similar things with 3D printing. So yeah, so all that kind of stuff, we definitely teach you how to design for the tool and how to use the tool itself.
Does anyone else have questions about stuff that we do, can do, or something you want us to do? So yeah, so I'll start moving on into our Arduino 101, but just feel free, if you have any questions, please drop them in the chat. We are looking at the chat and we will answer all your questions. Okay. So if you want to just follow along and you don't have an Arduino with you, you can go to tinkercad.com. However, Tinkercad has been down for a while recently, so you may not be able to do that. We're looking very hard for other online softwares that you can like practice doing Arduino or like simulate an Arduino. If any of you have another good resource for doing that, please drop it in the chat and we'll let everyone know they can use that. However, if you have a physical Arduino, you can download this Arduino IDE. So this link is a little bit long. Someone can paste it in chat. You can also just Google Arduino IDE, and this should be one of the first few links that come up. Where do you recommend getting materials for Arduino? What software do you recommend? Sorry if you already answered these questions. I came in a bit late. No worries. Please ask any questions you have. So for getting materials for Arduino, obviously you can go to the official website and stuff like that, but those will be usually more expensive.
Way more expensive.
You can always get most of these materials from Amazon. So most of what we order throughout the year comes from Amazon, or in fact all of what we order comes from Amazon, and we always get good materials that we use throughout the year. And software, so for Arduino, you only need this Arduino IDE. Yeah, and then the Arduino IDE, it's like there's a built-in text editor. It has like built-in interfacing with the Arduino board, and you can download upload code to the Arduino.
And for those of you that did come in late, we will be releasing a recording of the meeting that hopefully will answer any questions that you have. But if not, obviously feel free to reach out to us via the email address or by asking in any of our different social media platforms, and we'll answer your questions as best as possible.
Yes. We need to create an account for Tinkercad.
You may need to create an account with either Autodesk or log in with your Gmail, but the account is free, and I'm pretty sure you can turn off any spam emails that they send you. So yeah.
Okay. So, lesson 1. What is a breadboard? This is a loaf of bread on a cutting board, but this is a breadboard for an Arduino person. So, okay, so see, what's the best view for you guys? This one. Okay, now you guys can see this is a breadboard. Oh my goodness, camera angles are hard. Okay, as you can see, we're all struggling doing everything virtually. So this is a breadboard. It's just a series of like little ports that wires can go into. So I will do my best to show you guys what I'm talking about. So have this board, there's a better screen, and then you can like stick the wires. Yes, this is much better for you guys. You can stick the wire into the breadboard. So as you can see, there's like this blue and red line, and the same on the other side. So those are like your ground rails and your power rails. So the blue one, I don't know if you can see, it has a minus. That's very blurry, you guys can't see it. But the blue is, the little symbol at the top is a minus, the red is a plus, the blue is a minus, and the red is a plus on this side. So what you would do is you can connect the ground pin from the Arduino. So we'll show you the pinout from the Arduino in a sec. But basically you connect the ground pin of the Arduino, and then you can connect the power from the Arduino into this red rail, right? And then so this entire red rail is just connected underneath this port layer, under the plastic. And then the entire minus rail is connected, same on the other side. And then in the middle section, you see you have like a big grid of little wire ports. So each of these are in rows of 5. So these 5 are all connected to each other. These 5 are all connected. These 5 are all connected. So essentially you can connect something from your ground to one of these rails, and then you can connect something from your power, oh my, to another group, and then you can plug in something like an LED between, this isn't how you work with an LED, but then you can bridge that gap between the group that's connected to power and the row that's connected to ground. However, please don't do that with an LED, that would be sad. Okay, moving on. So what is an Arduino? This is an Arduino. So this Arduino is it's something called a microcontroller. So you can write little bits of code to it, and it will automatically run it when it's turned on. And then it just has all of these different pins that you can write to using the code, and then it will output different voltages from each of those pins. And then you can also send and receive messages between different Arduinos. They use something called serial communication. That's the same way that you download code when you plug it into this port. So it's using your USB, and that's using serial communication to write the code onto the Arduino board. So does anyone have any questions so far? That loaf of bread looked pretty rough. I agree. Does anyone have any questions so far about Arduino? Does anyone have a suggestion for our video layout being not optimal for you or anything like that? What is serial communication? You can take this one.
All right, yeah, so serial communication, so let me point this out on the board for you. So serial communication works a couple different ways. So on the board, I don't know how well you can see it, but you can see it on the diagram in the slideshow, that there's two pins on the right that are labeled TX and RX. That's your transmit and your receive lines. What you can do from there is you can send and receive data as like binary, right? So if I have like a string of text I want to send that's just hello, it'll convert the hello to binary, and then it'll just send it over the line. And then another Arduino would be able to receive it, and you kind of go from there. There's also other methods of communication. So there's I2C or I2C. That's a different protocol. And then there's also SPI, which is Serial Peripheral Interface. And that's another way that you can also communicate between different devices. So as we talk about and get further on into our workshops, we'll be able to show you guys more of the different communication protocols, and maybe we'll have a workshop that covers a little bit of serial. Yeah.
So on the left we have a little diagram of the pins for like each of the pins. So each of these pins can be used for multiple things. So as you can see on the left right here, it's a little bit small in the video. I don't think we have a layout that works best for this.
What are you trying to show?
But so in the recording, you'll be able to see the video pretty well. So it's like these.
Oh, sorry. You want me to send the PowerPoint in the chat so they can see a little clearer picture alongside of yours?
Sure.
Oh, okay,
yeah.
That's much more readable. Okay, yeah, that's better.
This layout works. Yeah. So along the right side, yeah, you can see that's hovering over, or actually you might not be able to see where the mouse is, but there's some teal blue on the right. So that's your SPI pins. The bright lime green is your digital pin, so that allows you to send 5 volts or 0 volt and read 5 volts and 0 volts. If you look to the left of the digital pins, still on the right side of the board, you see that there's tildes next to the numbers that are printed on the board. Those tildes mean that you can send values that are between 0 and 5 volts, not just 0 volts and 5 volts. And then let's see what else we have. So on the left at the bottom, we have our analog pins. So that is our that allows us to read values between 0 and 5 volts with 124 steps in between. So like 0 volts would be 0, 1 volt would be like 200-ish, and then 5 volts would be 1,023. And then at the top left, we have our like some of our power pins, and then we have the ground pins and stuff like that. And then at the top of the board itself, we have our power jack. So that allows us to give 7 to 12 volts DC voltage. And it'll automatically convert it down to 5 volts so that the board can run. You've got your USB port if you want to directly send 5-volt power, or if you need to do serial communication with the computer via the Arduino serial monitor, which we'll cover in a second, a little bit later today. And then you've got the reset button, which simply restarts your Arduino. What does the no connection pin? Well, the no connection pin is literally just a floating pin. It doesn't connect to anything. It's just there. As to why it's there, I have no earthly idea, but the Arduino folks that designed the Arduino decided they wanted a pin that does nothing. Yeah. Okay, let's go next.
Okay, so these are a couple of examples of something you might find in an Arduino kit. So there's a bunch of different types of resistors, and you can see there's different colored bands. So those different colored rings tell you what value that resistor is. So the one at the top with 2 oranges and then a brown and a yellow is 330 ohms. Gold. And then you have brown, black, orange, yellow, which is 10 kilo ohms. So as you can see, just with 4 colored rings, you can get a pretty wide range of different materials. So this is what a resistor looks like. It is extremely small. Maybe you guys can see it in the video. I don't know, you probably can't even see it because of how thin they are. Maybe you can see it on this. Yeah, it's extremely tiny. So those are resistors. And then this is a potentiometer. So it has these 3 pins, and you can rotate the top. So you see that little, I don't know if you can see the arrow, but I can rotate the potentiometer. And so this potentiometer, it's like a resistor, but as I rotate this arrow, it can change the resistance of the potentiometer. So you could wire up this potentiometer to, for example, a light or something, and that could change the brightness of the light, because when the potentiometer is at high resistance, your light is going to be dimmer, and then when you minimize the resistance of the potentiometer, that makes the light much brighter.
There's also like these wires that Mudit showed you guys earlier. So why don't we make this bigger, because we forgot to do that. Yeah, so there's the wires that you guys can see in my hand right here. So these are jumper wires. These specifically are male-to-male wires. There's male-to-female and female-to-female. So you can see the male-to-male jumper wire has 2 bits of metal, one on each end. So that allows you to connect one end to the breadboard and maybe the other end to a pin on the Arduino. So Mudit's doing that right now. All right, so Mudit's gone and connected one of the digital pins to
the PWM port 11 of the Arduino is now connected to this set of 5 pins or ports on the breadboard. And now anything connected into the other 4 in the same little column right here will be connected to the PWM pin 11 via the breadboard being connected under the plastic. Okay, and it is now time for the DJ light show. So, what do you need for this light show? You need your Arduino, you need your USB cable that connects to this port in the Arduino, and you need your breadboard, you need one LED, and if you see, it has like one of these pins is longer than the other pins. I know it's blurry, but you can probably still see the pin lengths. And so those 2 pins are telling you like what the positive and negative side of the LED is, because the LED is a diode, light emitting diode, and the diode tells you that current can only flow in one direction through that piece of hardware. And then, as you guys just saw, we need these little wires. Okay. So what is the first step? The first step, please let us know if you need us to zoom in or you can't see something, but we will connect the ground of the Arduino Let's get this bread. Yes, I agree. And then, so we first connect the ground to the minus rail of our breadboard, and that's always just a good idea to do. And then we can connect our 5 volts to the positive rail of the breadboard. So now we just have.
Why are you using the wrong color?
Oh my, I am using the wrong color. Okay, if you guys care, we should use the right colors. So we will now use red for power. I know. So just in general, having access to all of your ground and power pins is very nice. So I always the first thing I do is just plug in the high and low into the minus and plus rails of the breadboard. And then since we're just going to do a simple thing with our LED, we are going to now plug in a PWM pin, which is used to send, so we can send different values for the brightness. So we'll plug that into, let's just say, row 22 of our breadboard. And then our resistor is going to go from this minus rail into, we'll say, row 21. So now we have a circuit that's going from the ground to this minus rail, and then from the resistor to row 21 of the breadboard. And then we also have the other half of the circuit is going from PWM pin 11 to row 22 of the breadboard. So I'll bring this a little bit closer, you guys, so you can see. So the main thing is this blue wire right here connecting ground to the minus rail, and then the resistor going to row 21. And then we have a wire coming from row 22 into PWM pin 11. I know it's hard to see, it's pretty blurry, but we are doing our best with a live streamed tutorial. Okay, and now what you'll do is you'll connect your LED. So where's the video? Yes. So the longer pin is going to be connected to the positive part of our circuitry. So the positive power is coming from PWM pin 11. So I'm plugging that in right here. So as you can see, so the long pin is on the left, so that's connecting to power, and then the shorter one is connecting to the row with the resistor in it. Okay. Now we'll open the Arduino IDE and we will start coding. Okay. Get off this. Okay, 1 sec while we set up the view for you guys to see. Okay, yes. Okay, so as you guys can see, when you open a new file, it is going to look like this. Oh my, I'm struggling to type.
Right, so what it's typing right now is just the general format of the Arduino code file. So these are the two functions that you have to have. So what happens is that the setup function runs in the first, like when the Arduino turns on initially, and then the loop function runs in a loop once you write your code. So Jonathan or JJ just sent a link in the chat that allows you to kind of code up your whatever you want online. And then if you have a board, you can plug your board into your computer and do it from there. Okay. So another question. Someone asked us to distinguish the rows on the breadboard one more time. Yeah. So
here, grab another board. So let's. Okay. So you see this big plus and minus rail. Go ahead and give them a better view.
There we go. We're zoomed in a bit.
So again, it's blurry, but this red is a plus and this blue is a minus. So this entire area is connected under the plastic, and then the same goes for this minus rail. And then same thing on the opposite end of the board. So yeah, and there's also hopefully a more clear picture on the slide in the top left. And then so those entire rails are connected as you just saw. And then going across right here, they're in groups of 5. So if you can see, it's labeled A, B, C, D, E.
You can see that on the left-hand side on the breadboard.
Yes.
Right here.
I very much apologize for it being so blurry. So you have this like A, B, C, D, E, and then you have here, it's numbered. It's just numbered 1 through 65 for each of these little rows. So each of these rows of 5 are connected under the plastic.
Does that answer your question? Cool. All right.
Nice. Okay. Now let's switch back so you guys can see our code. Okay. So can anyone just like drop in the chat how this has been going so far? If you guys are able to follow along, if the video format is relatively convenient so far. Okay. So this setup function. So in the setup function, you will declare any variables that are going to save state for your whatever your project is. For this one, it's going to be very simple. We're just going to be just turning our LED on and off with a little delay sequence. So we're in our setup, we're also going to set the pin modes for every single pin that we're using. So right now, the only pin we're using is pin 11, and we need to set it to be an output pin. So you're going to type in pin mode, and then we're going to put in 11, and then all caps output. So this is setting pin 11 to be an output pin. And then in our loop, we are going to do analog write. Right?
Yeah, do analog.
Yeah. So we're going to write an analog value. Okay. Never mind. We're going to do a digital write because that's simpler, and we just want to turn it on and off. We're not very worried about the brightness of our light. So we digital write to pin 11, and we want to set it to high. Now let's compile this. So we click the little check mark, and then once that has compiled, if you can see right here it says compiling sketch, and it is going a little bit slowly. Okay, and it is done compiling. Now we upload to the Arduino. And as you can see, the light turned on. Hopefully you saw that. So now the LED is bright. So it looks white in the camera because the camera is kind of low quality, so it doesn't really get the red color. But it is in fact a red LED. So now what we can do in our code is add in some delay. And then so we'll say after 1 second, or so,
1,000 milliseconds.
So the delay is written in milliseconds just so that you can get more granularity without having to use a bunch of decimals. So we delay for 1,000 milliseconds, and then we digital write to pin 11, and we set it to low. So that'll turn it off. And then we upload it to our Arduino.
So you'll notice that the light stays on. Can you move closer?
Yeah.
So you'll notice that the light stays on, that the fact that we turned it low didn't do anything, right? And the reason for that is because if you think about it, the code that's in the loop function runs like back to back to back, right? So if you think about it, then we set it to low and we instantly jump back to setting it to high, right? So it doesn't stay low for any time at all. So now we're going to fix that.
Now we add in the delay after setting. Nope, I cannot code. Then so once it's set to low, we then wait another second before the loop starts again, and we set it back to high. And then we wait, and then so now we should hopefully get what we want. You can see it's off, and then it turns on, and then off, on, off, on, off. Right? So obviously this is a very simple program. You could do a lot more. You could you could totally use these delay values as some sort of theme song. So you could do like delay 100, and then you can do delay 200, and then you can basically figure out whatever numbers you wanted, and then it'll slowly flash like maybe the tune of some song. So that is how you make your own DJ light show with just an Arduino or breadboard and an LED. So that is it for this quick tutorial. Does anyone have any questions in the chat about what we have done so far? Can you explain again why we need the second delay? Yeah, so if we look at our code, so this loop is exactly what you think it is. It's a loop, so it's running over and over and over. So when we don't have this delay right here, you write it to high, and then you delay 100, and then you write to low, and then you immediately call the loop again. So that's kind of similar to doing this. So it's like you high, wait, low, and then you're immediately calling high again. But that isn't what we want, right? We want to have an extra delay right here that makes it wait a little bit of time before running the loop again. How does this work for multicolor LEDs?
Yeah.
So multicolor LEDs, instead of having just, as you can see, this one has just the one long and the one shorter one, but a multicolor LED would have a lot more, so it would have 4 pins, one ground and then an R, G, and B pin. So then the same way we're sending pin 11 to be the main just like power pin for this LED, you would have like pin 11, pin 10, and pin 6. Those are all 3 PWM pins. So you could each of those 3 to write to a different color of the LED.
Yeah, so I think Jonathan JJ just sent a RGB LED. So RGB LEDs come in 2 flavors. So what it just mentioned is the common
ground.
Is the common ground variant. So that's what you'll see when you have like a standalone LED that's just like that looks the same as this red one, except it's got 3 colors. There's another version that's a common power LED. So the common power LED is so the common power LED works a little bit different, and maybe we can cover those in another workshop. But yeah.
So Angela's asking, can you sync the LED to an actual song without hard coding the delays? So if you had access to like the sound file, like that would be pretty hard, but essentially what you can do is map the LED's like power level to like the output of the audio output of some sort of song. And then essentially, so the way the power level works is just like alternating like highs and lows. So then this light would just more or less follow along with the beat of your music. So that would be a much more complicated project. So there's a lot of different tutorials out there for doing this. Maybe we can have one of our workshops be about that if that's something you're interested in.
So another thing you can do, Angela, if you want to make it like play to an actual song, and say like you want to have this like maybe with more than just one LED, but you want to have it like at a party or something, right? What you can do is
no parties during COVID.
Yes, no COVID parties. But you can take your audio that you're playing through your speakers, and you can get a speaker module for the Arduino, and then you can grab the frequency off of that. And then if you want to synchronize to like the base hits, you basically would just on the Arduino say, if the frequency is less than this number, the light's on. If it's greater than the number, then the light's off, right? And then you could also do like different colors for different frequency ranges or whatever you want. So yeah. Yeah, so Emmanuel, that's actually a really cool project. That's definitely something where what I just mentioned with the microphone would work, right? So you grab the microphone and you would keep like, let's say you keep an array of however many light colors are in your NeoPixel, right? So a NeoPixel LED strip, for those of you that don't know, is an RGB LED strip where I can set the color of each individual RGB LED. From there, what you can do is you could use like a microphone to then grab the frequency and then store the frequency. You map the frequency to a color, and then you store that color in like an array, right? And then every time then you just iterate over the array and you set the individual colors. So you could definitely do that with a NeoPixel strip and a microphone. All right.
So, how was your first Arduino tutorial?
You guys want to let us know in chat or just unmute yourselves and let us know? That'd be great.
It was great. Thank you guys so much.
Yeah,
Yes.
you're welcome.
Great. Okay, so thank you everyone for coming. As usual, just put any questions you still have in the chat. So we'll post those links again. There was quite a few, and we want you to tell us what you want to do this year. So obviously, this semester is very different for us. We're having our workshop centered around you guys just because of the format. So fill out that survey. Tell us what you guys want to do, and the most important thing is for you guys to have fun. So obviously, this club is pretty different from most of the CS clubs. So we just want you guys to have fun and make some friends this semester. And then maybe in one of our more normal semesters, we can get into some serious projects with all this stuff.
All right, yep. And JJ just sent the list of links. So please join those, and hopefully you'll be able to get our updates. And yeah.
Yeah, and yes, we will. For those of you who are leaving, we will see you next week. And I will just put up the slide with all the links so that you guys can look at them and open them if you so please. Once again, thank you everyone for coming. If you have any questions, just drop them in chat, and we are still checking those. We'll stay on here for a bit if anyone has questions.
Yeah, so we'll post a link to the recording and all of the links in the Slack and Discord for you guys. That way you'll be able to check it out. We should also be able to grab a slightly higher resolution recording off of the OBS that we're using to do all of our different scenes. And we can kind of put that up as an unlisted YouTube video or something for you guys to check out. All right. If there's any more questions, please let us know. But otherwise, we'll go ahead and close out the meeting.